Okay. We want to talk about ideal efficiency. Okay, now. When I was a kid, I worked on cars. And one of the things we did when we worked on a car was we ran it for like 10 minutes and literally felt how quickly the engine got hot. And if it was extremely hot very quickly, there might have been a problem with it. And then we would also check the exhaust. And if the exhaust was also hot, it needed a tune-up. Now, what does that have to do with what we're doing now? Well, the greater the difference between the two reservoirs, the high temperature reservoir, remember the high temperature reservoir at the top and the low temperature reservoir at the bottom? The greater that difference, the better the efficiency, for instance. And this is something that's important. Kelvin only. Why Kelvin only? Why do we only work with Kelvin? Look at that equation. Why do we only work with Kelvin? Because you can't have 0 in the denominator, right? Would make no sense, would it? So we use Kelvin. Now, let's say the difference in temperature between the high temperature reservoir is 400 Kelvin and the low temperature reservoir is 300 Kelvin. What's going to be the efficiency of that engine?
0.25.
No. Oh, 0.25, yes. 0.25. It'll be 400 minus 300 over 400, which equals 1/4. 0.25, right? Easy? Okay? So what would be the efficiency if the high temperature reservoir was 400 Kelvin, right? And the low temperature reservoir was 100 Kelvin. What would the efficiency be? 0.75, right? Unlikely, 0.75. You see how that works? So you see the difference in the reservoirs. If an engine's running hot, if the exhaust is hot, now again, I said this in another film. Well, what's the evidence that a car is a very poor way of transforming heat energy to mechanical energy?
A lot of exhaust.
A lot of exhaust.
And it's hot because
the engine's hot. I mean, to touch it. So, if the engine's hot,
that means you're not getting the full amount of energy.
Right. That means that energy that you feel is hot is not being converted into mechanical energy. Correct? Yes. If the exhaust is hot, that means that energy is not being utilized for mechanical energy. So think about this. Think about it just for a second. What would be a more efficient, just based on that whole idea, what would be more efficient? Going at high temperatures for a long period of time, like interstate travel, or stop and go around town where there's very little flow of air into the engine? What do you think? What's a more efficient way of doing things? It's the traveling at high temperature, at high speeds over long distances. That's a much more efficient. You get much better gas mileage. You ask yourself, well, wait a second. I don't have to worry about measuring the ideal efficiency of an engine. How do we do that? How do we measure the efficiency of an engine?
Miles per gallon.
Yeah, the miles per gallon, MPG. If your car is rated at 25 miles a gallon and you go fill it up, you fill up your car, right? You make sure you top it off so it's full. You come back, you get gas another time, you write down how many miles you went, You top it off and you find out how many gallons you put in your car. Miles per gallon. My father used to do it all the time. Every time he filled up his car, he kept a ledger, hundreds of pages of numbers. He wrote down how many gallons it took to fill up his car. You just look right on the pump. How many miles he went on the odometer, and he figured how many miles per gallon he got every time he filled up gas. And if it was starting to decrease the miles per gallon, he went and got a tune-up. So, you know, this whole idea of ideal efficiency is done all the time. As a matter of fact, car companies produce 20 miles to the gallon, 30 miles to the gallon. But does that tell you how efficient relative to ideal efficiency an engine is? No, it's relative. Your car is better than her car. A car, a combustion engine, is a very inefficient way of doing business. So when you talk about MPH, miles per gallon, it's miles per gallons of Luke's car versus miles per gallons of Blanca's car. If his car is 30 miles to the gallon and her car is 15 miles to the gallon, his car is much more efficient. Is it very efficient? No. It's simply more efficient than her car. I would rather buy his car, I'd save on gas. If you look at cars on fuel cells, and Michael's going to do that report, look at how many miles per gallon, miles per fill-up, how much the cost of going 100 miles is.
What was the question? How much it costs?
Yeah, like how much it costs. You go to your pump. I just got my car filled up yesterday. It was on E. It cost me $45 to fill it up. Okay? Now, and I can go for a week and a half. My commute to work's not much. So it cost me $45 every week and a half to fill up my car. Right? Yes? So how much will it cost to go for a week and a half? You know what I'll do? Right now, I'll go to the get more gas today. I'll write down all the figures. And then in a week and a half, when you have your presentation, I'll give you the numbers on my car. And we'll compare them. Have a great day.